Hello everyone. Today we're studying system of equations. A system of equations is a set of two or more equations with the same variables and they share a common solution. We're going to solve this system of equations by using several methods, and today specifically we're using the graphic method. We'll graph each equation on the same coordinate plane, and the point where the lines intersect is the solution to the system. It's like finding where two roads cross on a map, okay? Okay, in order to graph, we need to remember that we need them in slope-intercept mode. And how does the slope-intercept form look like? It looks like this. Y equals mx plus b, which means that we need to turn these equations into this one. The first thing you notice is that y is isolated. So what we're going to do is to turn these into something with the y isolated. So I'm going to take the first equation to x plus 3y equals 15, and I'm going to isolate y. 2x, that is, you see is positive, goes to the other side negative, which is then 15 minus 2x. And 3, that is multiplying y, goes to the other side dividing, which gives us this. Now, 15 divided 3 is something I can simplify. That equals 5. But 2/3, it's something I cannot simplify into an integer. That's why I'm going to leave it just like that. Now, it doesn't matter if it's not exactly in the same order, because I just know that the slope is negative 2/3 and the y-intercept equals 5. So this equation now looks like this. 5 minus 2/3 of x. I could write this thing first with the negative sign and then plus 5, but I'm going to leave it just like that. I'm going to do the same again, but with the other equation. And it looks like this. So I'm going to isolate this y right here. X, that is positive, goes to the other side, subtracting, meaning that I have this. Now, negative 3 is multiplying y, so it's going to divide right here with the negative sign. We should remember that we change the sign because we're doing the opposite operation when adding and subtracting. But when we are multiplying or dividing, the number keeps the same sign. That's why I could say 3 divided by negative 3 plus negative x, minus negative x divided negative 3. So 3 divided by negative 3 is negative 1. X divided by 3 is x thirds, but if you notice, both of them are negative, so it turns into a positive number. Now, do we want this to look the exact same way as this? Well, we're going to do two things. We change it, and that would be it. Or we do this. And I would realize that my slope is 1/3. So this equation turns into y equals 1/3 of x minus 1. Again, It doesn't matter if I have it in this order or in this order, as long as I have the y isolated. Now we can proceed with the graphing. Okay, now I'm going to graph here in this part what we have done. I'm going to write first the two equations that we had. Those were y equals 5 minus 2/3 of x and y equals 1/3 of x minus 1. So what do we need to remember here? First of all, the numbers that are next to x are the slopes, and the numbers that have no x are the y-intercept, okay? So what we're going to do is to start with the y-intercept. I'm going to start with this one. So the y-intercept is 5, which means that I should stand here in 5, and that is the first dot that I'm going to place. And from this y-intercept, I'm going to move 2 steps in the rise and 3 steps in the run. Since this is negative, and the sign is important here, we are moving 2 steps down. 1 and 2. I'm going to slightly do it so you can notice it. And then 3 steps to the right, which is then 1, 2, and 3. So the dots I'm going to connect are those two. I'm going to quickly do it. And I have them there. Now I'm going to use a different color. Maybe I'm going to use blue to do the second equation, to graph the second equation here. So the y-intercept is -1, which means that in -1, in y, we're going to place our first dot. And from that point, we're moving 1 step in the rise and 3 steps in the run, meaning that I'm going 1 step up because it is positive, and then 3 steps in the run, which means that this is the point we're touching. And now we're going to connect those two. So it is like this. Yes. Okay. Here. So I don't know if you notice that this is the place. I don't have a different color. Maybe I can use this marker. This is the place where they collide, where they intersect. That means that there is the solution. What are the coordinates of this point? They're 6 in x and 1 in y. That means then that the solution for these systems of equations is x equals 6 and y equals 1. And this is the solution of our problem.